Hi, let us talk about this problem. We are given an array of integers. We need to find out maximum value of array j minus array I such that j is greater than I. So I and j are two indexes and j has to be greater than I. Let's see this example. We have an array of integers. What is the maximum difference between two integers? Such that we subtract the first appearing element from the later appearing element. So when we talk about this pair, we need to subtract 2 from 10, right? So we subtract array I from array j, where j is greater than I. So if we consider all pairs, we can see that we get maximum difference with 2 and 10. For example, if you consider other pairs like 3 and 10, you get the difference as 7. If you consider 3 and 6, you get the difference as 3. If you consider 6 and 10, you get the difference as 6 minus 10. Please note that we need to subtract the first appearing element. So 6 minus 10 is minus 4. If you consider 10 and 4, you will get minus 6. If you consider 4 and 8, you will get 8 minus 4, which is 4. So we need to find maximum of array j minus array I such that j is greater than I. Let's see this example. So this is the pair which is giving us the maximum result, which is giving us 2. If you consider any other pair, you are going to get less value. For example, if you see 5 and 9, you are going to get minus 4. If you consider 6 and 5, you are going to get 1. 6 and 3, you are going to get minus 3. 6 and 2, you are going to get minus 4. So our result is 2, which we get from this pair. Let's see this example. This is a sorted array. So if you have a sorted array, you get the result as last element minus first element. If your array is reverse sorted, then your output is definitely going to be negative. And what value you will get? If you consider all adjacent pairs, you get the difference as minus 20 here, minus 2 here, and minus 6 here. So you get the output as minus 2, which is the maximum possible difference. Now please pause this video and try to think of a solution for this problem. We are going to talk about two solutions. The first solution is going to be big O of n square. Then we are going to talk about a solution which is going to be big O of n. Here is naive solution to solve the problem. And I guess most of you must have guessed this naive solution. What we do is, we initialize our result as difference between first pair. Now we consider every pair. For I equal to 0, we consider all the elements from 1 to n minus 1. And we find the difference between that element and 0th element. And if this difference is more than the current result, we update the result. Then we do the same thing for I equal to 1, I equal to 2. So basically we traverse through all the elements one by one. For every element, we go to right of it and consider every element as array j, find the difference and check if the difference is more than maximum. So we'll begin with 2. We'll go to every element on right of it, find array j minus array I. That's what we do here. And then we'll come to 3. We go to every element on right of it, find array j minus array I. And if that difference is more than the current result, we update the result. What is the time complexity of the solution? This is clearly a theta n square solution. Now please pause this video again and try to think of a solution which is theta n. Let us now talk about an efficient solution. The idea is this. We consider every element as array j, the right element. And we also keep track of the minimum element so far. So every element, array j, can give you the maximum difference when you consider minimum element on left of it. So you simply traverse the array from left to right, keep track of the minimum element that you've seen so far, and for every element, you subtract minimum element from it, and then you see, is it giving you the more difference, more value for the result that you've found so far. That's all you do. And you also make sure that you update the minimum element whenever you find a smaller element. Let's see this with this code. So we initialize the result as array 1 minus array 0. We initialize the minimum element as array 0. Then we consider every element as array j in this expression, right? And what we do is, we check if this array J is giving more difference than result with current minimum value. So the trick is, we are not considering every I for array J. We are only considering the minimum value and updating the minimum value when required. So if this is giving more difference than this current result, we update the result as maximum. And if this element itself is smaller than the minimum value that you've seen so far, then you update the minimum value also. That's the simple idea. And you finally you return the result. Let's do a try run of this for this array. So we have this array. We initialize the result as difference between these two. We initialize the minimum value as this element. Now we run a loop for j equal to 1, 2 and minus 1. We find the result. We check if the array j minus minimum value. So what is array j? Array j is 3. What is minimum value? 2. So this difference, is it greater than the current result? No. So we keep the result as 1. Now we find the minimum value. Is the current value smaller than the minimum value? So what is your current minimum value? 2. And current value 3. So you do not update the minimum value also. It remains 2. Now we come to the next element 10. Our j becomes 2. We find, is this element 10 giving you more difference with the minimum value so far? So 10 minus 2 is 8. It is actually more. So we update the result as 8. And we also check, is it the value is smaller than minimum so far? It's actually not. Our current minimum is 2. So we do not update the current minimum. Now we come to 6 and we repeat the same process. We find the difference between 6 and the current minimum. We get the difference as 4. We compare it with the result, current result. It's smaller than 4, so we do not update the current result. Then we check, is this element smaller than the current minimum? No. So we do not update the current minimum. Similarly, we'll traverse the remaining array, and this is the only point where your minimum value will be updated. Otherwise, it will remain 2. Basically, just finding the minimum value that you've seen so far. Right? So it's 2 till this point. And your result will never be updated, because for this you will get 6 and you've already got 8. And for this you will get minus 1, which is definitely smaller than 8. So your result is going to be 8 and your minimum element after this loop is over is going to be 1. And this is how you get your result. So basically what all we have done, we have kept track of the minimum element that we have seen from the left side, and we are considering every element as array j. What is the time complexity of the solution? It's clearly theta n solution, and it requires theta 1 auxiliary space.